live button. Okay. Okay. In theory, we went live. As you try to pretend to not be chewing food. I know. This is what you get when you are busy all day long.
Well, and I didn't even really realize how hungry I was until my stomach made this like noise where I'm like, Richard and Allie are going to be able to hear that.
That's awesome.
When your stomach decides to join the soundtrack for the podcast,
Yeah.
it's time to go grab non-crunchy food.
Yeah, grab a snack. Hey, everybody. So now's your chance to say hello. Say hello to me and Pamela, and then we will say hello
Acknowledge
back.
you.
We will acknowledge your existence.
Hello, Wayne Johnson. Hello.
Are you?
I'm on
You're
Twitch.
on Twitch? Oh, okay, all
Yeah.
right. I'm going to say hello to Ben Lowe, Dwayne Duvall, Guido Bibra, John Suffield, Johnny J, Keeper of Maps, Quad Libet, Linda Sadiq, Lionel L, Michael Meyer, Michael Paling, Nancy Graziano. Woo! Nancy Graziano's here. Paul Disney, Rich Wilson, Uncle Bill Druin, and Zap Van Zappen. Nancy had a job and now she gets to have her Friday afternoons off, and so now she gets to join us, which is awesome. Corey S., Max Newell, Janelle Duncan, Beth Johnson, Linda Sadiq, I don't know if I already said that, Tesla Ranger. There you go. Hello, everybody. What's happening? It's been kind of boring, space news-wise.
And then last night, there was like all the galaxy news. All of it.
Yeah, with the Dark Energy Survey.
Yeah.
Is that a show? Because it's like 29 papers.
Yeah.
It's
no,
they dumped
that's
a
something.
big. Yeah, okay.
I'm gonna review what we have planned for the rest of the season and see if I want to sneak that in there.
Mm-hmm.
But it's gonna take a bit of reading to go through and process everything
29 papers
that was
get to
figured
work.
out.
Yeah, I mean, we're just gonna. Yeah. I mean, with Universe Today, we're gonna sort of hit the first part, just the big picture that this thing is done. The first version of the survey, 3 years, as I said, 29 papers, 226 million galaxies, a sphere 7 billion light years across. It's a big piece of news. Einstein may be wrong, which
that
is
one
interesting.
I hadn't seen yet.
Yeah. So
what's the
I forget
411?
I forget. I haven't dug too deeply, so I wasn't exactly sure, but it was like the weird things that are turning up with cosmology are not hiding in the error bars. There's clearly an update to the physics that's going to need to happen. So
that's cool.
Yeah.
So I have a few more people to say hello to.
Okay.
I can say hello to Planetary Panda, Veronica Cure, to Ian JF40, to Bad Panda Bear. Hello, peoples of Twitch.
Okay. All right.
I put my Percy notes somewhere. Oh man, I have so many screens. One moment.
First
there
world
they are.
problem.
Nope, that's not it. Still not it. How many windows can I have open? I think the answer is all of them.
The less the better.
But nope, still not it. So what ends up happening is I'll get a notification telling me I must have closed the window that had my Percy notes in it. That was stupid of me. I'll get a notification and then I'll click on the notification.
Mm-hmm.
And then there are all of my tabs. And then I'll have a new like email window. and they just like end up replicating. And at the end of the day, I'll have like 12 tabs all open to my email. Hi, Sneezy Dog. You done? Okay, dog is done.
Sure. Okay. Tell me when you're ready.
I am pressing record.
I have also pressed record. Okay. Here we go. Astronomy Cast, episode 608. Perseverance rover, 100 days and rolling. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. We didn't get hit by tornadoes yesterday, which is always a plus.
So far.
And well, yeah. Well, yesterday is past. So I feel safe saying yesterday we did not get hit by tornadoes.
Right.
And spring is here. The yard is aflower with weeds. And we're heading into Memorial Day weekend, which means all the yard work shall be mine. How was your Victoria Day?
Oh, it was relaxing, and we celebrated Queen Victoria in every way that a Canadian does, which is not one bit. So yeah, but I didn't do anything, which was nice. Like we camped. I didn't do any work. I didn't even do a show on the Monday. I took the whole thing off, which was great. So I was awesome. Rested and relaxed, and I'm ready to talk science.
Good.
Now, as you all know, Pamela refuses to talk about any missions which aren't actually doing science. Well, Perseverance has crossed the line from fantasy to an actual working rover, scooping regolith.
Said yeeting.
Is that incorrect? Do I have to just say yeet? Is yeeted?
No, you said it
yeeting?
You are conjugating it correctly. It is a glorious concept, and it is exactly what this little rover has done.
It didn't.
To that impossible little helicopter.
It gently placed it on the ground and backed away slowly and nervously, I think is the better way to describe it. Yeeting is not what happened.
It's true.
Yeah. So Perseverance, what is it?
It is a next upgraded version of Curiosity rover. It's built on very much the same hardware plan, but as happens when you get a few years from one design to the next, they upgraded the systems. And part of upgraded the systems meant it has a belly full of crazy robotics and electronics. And they're going to use that crazy belly to gather up samples of rock. It also is carrying the first ever microphone on Mars, which people are far more excited about than I ever dreamed.
Like me.
Well, yeah, it still caught me by surprise. And they have an experiment for creating oxygen. They have a laser, and they are zotting rocks left and right. And then, of course, there's the little Ingenuity helicopter.
All right. So then, like, compare and contrast. Like, if we had Perseverance and Curiosity side by side, and we were looking at them, trying to spot the differences, they're the same size, right?
They're the same size.
And they're roughly built on the same chassis.
Yes.
Okay.
So the heads look very similar. It's when you start looking at the arms and the underbelly that everything radically changes. There's a phone ringing. I'm so sorry. Let me hang up on this. Go away. No, I hung up on you. All right, we are continuing. It's when you look at that underbelly and arm that everything radically changes. So this arm does not have the little divot scraping machine that they have on Curiosity that they've been using to rove up to rocks and remove a layer of weathered rock to see what's underneath. Instead, the arm has Sherlock, which is an ultraviolet spectrometer, and it has a laser. And they are literally zotting rocks and listening to hear how the zap sounds. And using that sound, they're getting an assessment of the density and other
Whoa.
characteristics of the rocks. This is not something I imagine. This is the moral equivalent of doing science by knocking on wood, except they're zotting rocks.
I had no idea that they actually had any kind of scientific purpose for that microphone. I just thought it was literally just to make some of us out there who wanted to finally hear the sounds from Mars happy. But no, it turns out they've got a job for that. That's really cool. So
Yes,
they've got a microscope on this
they do.
on the arm.
Yes. And so they also have the spectrometer. So there's the Watson camera and the Sherlock spectrometer.
Right.
And between the two of these, they can take extremely high resolution images of that rock they are zotting, or they can look at how light reflects off of it to get a sense of what is inside, what the chemical composition is. And what's kind of awesome about this entire setup is they're currently using it to explore what might be a meteorite from another world that landed on Mars. So apparently we sent a rover to Mars to look at rocks that fell from space from who knows where.
Right. Right. Probably Mars.
So we don't know.
Right.
There's this weird looking rock. It was one of the first things that people noticed looking at the images. It looks like it has a bunch of deep pits or holes in it, like a Texas Holy Rock, a piece of basalt. There's meteorites. There's lots of different ways to get this weird pitting texture to a rock. And the way it's just sitting there hanging out looks kind of like what you would expect from a meteorite hitting and hanging out on the surface while the landscape around it gets blown about by dust and wind.
I've seen that rock. We get that in driftwood, where you've got a piece of wood that had been beetle devoured, and it has all these little drill holes that makes it look really pockmarked, and then it floats in the ocean and I guess shows up on your shore. Who knows where it started out? But yeah, I know exactly what you're talking about. So those are the differences. The arrival at Mars went pretty smoothly. We saw much better video, photographs this time around. We got to
and they got higher accuracy on landing due to different cameras.
Mm-hmm.
So they actually have started using machine vision to help steer not just the landing of the rover, but also this is how they steer the helicopter in part. And so as they were coming down, they were comparing the maps they had of what they expected beneath them and steering accordingly to make sure they got where they wanted to go.
Right. All right. So now we've given you mostly an overview of how the rover itself differs from Curiosity. We're going to have a break, and after that, we're going to talk about what has been discovered by Perseverance on Mars so far. See you in a couple of seconds. And we're back. All right. So we know that it's got a microphone. We know that it's got a helicopter. We know that it's got all these additional things. So what has this rover been up to?
So mostly it's been babysitting a helicopter, which is when I scheduled this 100 days of Perseverance, I was really expecting a lot of Perseverance because back in the days when we had Spirit and Opportunity, they weren't expected to last that long. They hit the ground, they roved, they made science happen. And Percy landed and is like, okay, I'm going to take my time. I'm going to rove over to this nice, smooth area. I'm going to drop my helicopter back away 100 feet. I'm going to watch my helicopter. And so it hasn't done a lot of science other than technology testing. Now, some of that technology testing it's done is truly remarkable. Another one of the instruments it has on board, and instruments is really the wrong word. Another one of the pieces of equipment it has on board is MOXIE. This is a system that pulls in the carbon dioxide rich air that is the atmosphere on Mars and puts it through a lot of heat, a lot of pressure, and separates with an electrode the oxygen off leaving behind an oxygen, a carbon monoxide molecule. It releases that carbon monoxide back into the atmosphere and collects the oxygen. And the hope is that eventually, instead of having to send the 25 tons of air that astronauts are going to need to survive a typical Mars mission, they're going to send a 1-ton oxygen creating factory. And MOXIE is showing that this just is a feasible option for the future.
Now, I'm going to shamelessly self-promote an hour-long interview that I did on my YouTube channel and podcast with the principal investigator of the MOXIE experiment. And so if you want to understand the limits of this, how it's working, what are the constraints, why even test it on the surface of Mars, and more. I spent an entire hour talking with the principal investigator. So you can go into a tremendous amount of detail, and it was really fascinating. One of my favorite interviews. And so if you aren't already subscribed, I don't know if you're subscribed to Astronomy Cast, but you're not subscribed to my podcast, you might want to do that because...
and that's Guide to Space?
Yeah, just search for Universe Today wherever you get your podcasts, and you'll find my 750-ish episodes as well. So, in case you run out of Astronomy Cast. Anyway, shameless self-promotion out of the way. Let's talk about the microphone.
So it's just a microphone, but they're using it in all sorts of different ways. They're using it, like I said, to listen to the rocks getting blasted with a laser. They have listened to the wind rolling by. They have listened to the sound that the wheels make as the rover roves across the surface to see if they can get a sense of what that surface is like from what it sounds like. As someone who used to own a Jeep Wrangler, I could usually tell what was beneath my Jeep when the top was off by listening to the various kinds of crunching noises it made. And they're doing science this way.
That's really cool.
It's just adding an additional sense to their little robot.
And I'm not going to lie, I'm a little underwhelmed. Not by the microphone, not by the rover, just by the sounds of Mars. Mars audibly sucks. And
it doesn't have enough air pressure to sound good.
That's right. And I think that's the big problem is it just doesn't have the air pressure. And so you're hearing like the laser firing, sounds like a clicking sound, or you're hearing the wind blowing or the rover crunching, and you're like, is that it? Is that all we got?
Yeah.
So I think we're going to need to see generations of audio engineers working with the sound to be able to do it. And so when you said, no, it's got a scientific purpose, I'm like, okay, all right. Then this microphone is redeemed.
Yes. Yeah. Yes. So far they have zotted rocks, they have roved, they have listened to everything. They have taken pictures of dirt devils, dust devils. They have taken panoramas to catch themselves and Ingenuity off in the distance. And they've done a whole lot of babysitting of Ingenuity. So Ingenuity is the first vehicle we've had that has taken off and landed multiple times. And just in time for this episode, it made its 6th flight and had its first fascinatingly, that looks like how I would fly a helicopter kind of moment.
Yeah. So let's talk about all the various flights then, or just briefly, just sort of talk about what has been Ingenuity been up to overall.
So the target goal was to test that it was able to fly up to about 5 meters, that it was able to fly around no more than 100 feet was the initial goal, and take images of what was below it. It is controlled off of basically the technology you would have in a cell phone or a Gulf laser distance indicator. And it uses a combination of all those accelerometers to keep track of what it's doing. And then it uses the images to get extra control. And it was those images that caused things to go wrong today, that it dropped an image and was then overcompensating because it didn't know what it was looking at when. But what's amazing is they know that throwing these things are hard, or rather flying these things is hard. So they built in all sorts of extra safety things.
I mean, the idea I mean, I would say already it's so exciting on just the fact that they've been able to make this thing fly at all in that thin atmosphere. And it's actually a fairly large propeller. It's turning very quickly. The gravity's a little
2,500
lower.
times.
It's really its only job. It's got like 2 cameras, a battery pack, a little bit of brain power, and a little solar panel, and then everything else is all propeller. But just this idea that you can have an autonomous scout deployed with your rover, there's no way this isn't going to be a standard that ride along with every single rover ever sent to Mars from here on into the future.
It's a buddy movie.
Yeah.
So they can't pick the helicopter back up. And it now has an extended mission, which means as Percy goes across the surface, it's going to have little Ingenuity flying ahead, lagging behind, basically flitting about, keeping up over time.
Yeah, it is interesting, though, you know, this thing that you mentioned that it's amazing and wonderful, but it is almost turning into a job for Perseverance, and Perseverance has work to do, which we will get into in a second, but it's time for another break. And we're back. So what is sort of like the big, we've talked about this many times in the past, not officially in any one place, but the fact that Perseverance's job is to search for the conditions for life in the past or the present. That's its job.
Yes.
And when it's not watching that needy helicopter, what has it been doing to further this task?
Well, so far it's pretty much been watching the needy helicopter. Poor Ingenuity doesn't have the power or the antennae to be able to communicate all the way back to Earth. So it's a relay satellite. It's a relay station for the helicopter right now. But this bleak task for the rover is allowing the mission team here on Earth to go, okay, you landed exactly here on Mars. I have all the imagery of Jezero Crater. We are going to plot the best path possible through the delta, through all of the different mineral samples. And that belly full of robotics that I talked about earlier is because this mission is going to go up to rocks, drill into them, use an arm to hold out a sample tube, let the sample that it's drilling go into the tube, pass it into its belly where another arm is going to grab it, going to hermetically seal it, and then put it into longer term storage. And eventually, after enough of these little sample cups are filled, it's going to deposit them all somewhere, like so many science eggs waiting to hatch into new results. But we're going to have to send a second spacecraft to go pick them up and bring them to Earth. So
you say laying eggs. I like that, because I've just been describing it as pooping. So if you're going to say that it's laying eggs, I think that's, that seems
you don't want to
eggs.
collect poop the same way, not unless you're like that kind of a biologist, in which case microbiomes are cool. Right. But it's laying science eggs. This is how I choose to look at it. So then, I mean,
what are at the point that we're at right now, as you said, it's really been in this test out phase. It hasn't had a lot of time to do science. The science gets to work. What are the things that now Perseverance is going to be looking for that will really advance its mission forward to give us some kind of concrete answer about whether or not there were the conditions for life on Mars?
So the area that it's in is the most, yes, there was water here kind of structure that we've put a rover in so far. There is a river delta looking area. And the kinds of minerals, the kinds of organics, just a little over 3 billion years ago that formed this area could have had life. And so it's going to be looking for the kinds of rocky formations characteristic of watery environments. It's going to be looking for the minerals that form in areas rich in organics. And if we're lucky, it's going to find things like stromatolites that say for sure, yes, there was critters here.
So sorry, what is a stromatolite?
Stromatolites are rock formations made out of bacterial mats. So if you've ever owned a fish tank, you know that stuff will grow and form slime layers, for lack of a better phrase. And over time, these layers can build one on top of the other, crushing down, drying out, forming a rock. And stromatolites are the built up bodies of formerly alive things.
Right.
And so these bacterial mats that layer up, die off, become fossils. That's about the most advanced we're willing to hope for life on Mars. And it would be amazing if we found these formations that we know we have here on Earth.
I mean, Spirit and Opportunity could have seen a fish fossil on the side of a rock on Mars. You don't need anything really special to be able to do that. They didn't find that. Curiosity would have been able to find that. It didn't find that. So Perseverance is taking that to the next level. And so even if it doesn't find the Martian fish, even if it doesn't find the Martian bacteria layer cake,
stromatolite.
Stromatolites, it could find, like, there was definitely water here, and there was definitely, the place was seeped in organic materials.
Yes.
And you kind of had everything that you needed to be able to have life. And then let's get those samples home to be able to test them out.
Exactly. Many years of adventure to go.
So what would be like like, I can remember times when we were looking at Spirit and Opportunity and they said, yes, water was, there are regions that were once had water.
Yes.
And it could have just been a flood, who knows? And then with Curiosity, it was like there were regions that had water for long periods of time. And so if you could, like, if people are just like watching the news from Perseverance, what is that thing that says science goal achieved?
Oh man. They have to build these rovers a little bit open-ended. Ideally, they rove up to something and it has the exact composition that you would expect in a fossilized riverbank here on Earth. That maybe even you see things that are clearly fossilized by volcanic ash going in and petrifying whatever used to be there. That's probably a little more advanced than we can hope for, but going through and seeing the diversity of minerals that map out the specific wetness, the specific temperatures that allow those formations to take place. That we can do. We know different minerals form in different conditions. It's going to go out. It's going to dig into those minerals. It's going to see exactly what is there. And hopefully someday something will go and pick up those samples and bring them back to Earth.
Did you want to just briefly touch on how the sample return mission will integrate with Perseverance? How's that going to work? As it picks up eggs.
So here's the problem. They don't have a second mission planned yet. They know someday something is going to have to go back to Mars and very accurately land, get the samples, and then have the ability to take back off on the Martian surface with the samples it has picked up. And we have no idea how any of that is going to happen. Mm-hmm. It's not currently a planned named mission with a window.
We know a few things. I mean, we know the plan.
Well, so the plan is to either send one or two more missions, one which is to go and pick the things up and have them in its hot little robotic hand.
The chase rover.
Yeah. And then the other is that launch and come back vehicle. And it's possible that could be a single mission in two parts or that it could be two different things that land. Mm-hmm. But we've never landed things side by side before. So there's a lot to be learned in the coming years, but we're going to watch it.
The cool thing about this is that it's a collaboration between NASA and the European Space Agency. So my understanding right now is that NASA is going to build the ascent vehicle. using something like MOXIE to help generate the oxygen for the fuel. So it's going to carry its hydrogen or some other fuel source, and then it's going to be able to make the oxygen on the surface. And that will test out what future astronauts are going to use. It will, so that will land on the surface of Mars in the vicinity of Perseverance. And then Europe is going to build the Chase rover, which will land and return samples from that, as well as the European Space Agency's rover, which is going to be roving in the same vicinity as well, which is going in 2 years. Got pushed back because of their problems with their parachute.
And it will stay dead to me until it actually takes off.
Right. If you're Pamela, you just heard wah, wah, wah. But for the rest of you listening, they're planning to build the European Space Agency's rover is almost ready to go. And that's launching in 2022. But then the Europeans are going to build the return vehicle, the sample return. So the Chase rover is European, the ascent vehicle is NASA, and then the return vehicle is European to bring all those samples back home. And that will be mind-bending to think that there will be a time in the next decade when we will have dozens of samples from the surface of Mars that were hand-chosen by scientists. Very cool. If all goes well. If all goes well. Very cool. Thanks, Pamela.
Thank you, Fraser.
All right. Do you have some names for us?
I do. As always, we are brought to you by you. We are so grateful for all of our Patreons at patreon.com/astronomycast who make this happen. This week, I would like to thank Lyle, Bruce, Benjamin Davies, Stephen Coffey, Kimberly Reck, Nalia, Dean, Neuter Dude, The Lonely Sand Person, Joe Wilkinson, Sean Freeman, who's Blixa the Cat, Frodo Tenenbaugh, Corinne Demptruck, Gabriel Gelfin, Daniel Lossley, Kensnia Panfilinenko, Alex Rain, Justin Proctor, David Gates, Arthur Latz Hall, Aaron Zegrev, Abraham Cottrell, Claudia Mastriani, Kathleen Matterson, Matthew Horstman, Roland Vormerdam, Jeremy Kerwin, Sabri Lark, Tim Garish, Omar Del Riviero, Brent Knopp, John, William Lauer, J. Alex Alexanderson, Ronald McCoy, Mark Stephen Raznak, Marco Arasi, Brian Kilby, Paul L. Hayton, Michelle Cullen, Aaron Tannenbaum, Dustin A. Ralph, and Leah Harborn. Thank you all so much for all you do. Because of you, we have Nancy, Beth, Rich, and Allie all running herd and keeping things running smoothly.
Thank you, everybody, and we will see all of you next week.
Bye-bye. And now they saved.
Then they saved. 608.
And I'm going to remember to put it in the correct directory this time. I keep trying to save Astronomy Cast into the Daily Space directory. And that does not, it works. It saves perfectly.
It sure does.
It's just can't be found by the editors.
Yeah. All right. And then Richard gives you a bunch of questioning emails. Where is it?
Well, he usually knows exactly what I did. And he's just like, can you go move it? So.
Okay. I'm just going to get my upload.
I'm going to find the Twitch window. Oh, something happened to the feed.
Which feed?
Ours, apparently. I don't know what happened.
On Twitch, not on YouTube.
No, it says happened on YouTube too. Shakes fist at YouTube.
Oh, that was way back. That was way back at the beginning.
Oh, okay.
Yeah. Yeah, people were having a problem with it way back in the before times.
Okay. Yes, Sita, that was totally live.
Was that live? Or we have some kind of artificial intelligence system that's running that detects when people are asking if this is live, and it says, yes, this is live. Yes, this is live. Deep faking ourselves.
There'd be more glitches in the Matrix.
Hit us with your questions. This week, I promise, we'll focus just on space questions. We won't talk about swallows and whatever nonsense we talked about last week. Janelle Duncan, how many samples are waiting to be picked up on Mars?
Currently 0. Mm-hmm. There will be many. And what's cool is 5 of the sample containers won't actually get stuff put in them. They have little minerals in them that will absorb the atmosphere. And those are the control ones to try and figure out how much of Earth we took with us.
Oh, interesting. Okay, I didn't know that. That's really cool. Smart.
And they're the 5 controls.
Why do you need 5?
They're going to open them at different places to take samples of the, like, what happens if you just hold them out there.
Got it. Okay. What if you...
So they'll go through all the motions of taking a sample without actually drilling to get the sample into the tube.
Right. And in different environments to sort of see how it's different. Got it. Okay. Yeah. That's really smart. Okay. I don't know how a chase rover picks those up, though. Just like picking up just ghosts. Because there's nothing there. I'm sure they'll have a different way of storing those samples then. Because after a while, it's just going to be ditching. Like, it has more sample bags. I don't know what that... Tubes?
They're tubes.
Yeah. Has more tubes than it has room for internally. And so after a while,
and they're talking about laying two sets of eggs.
Right.
Tubes. 2 sets of tubes.
Arjone, will the samples be handled in a high-level biosafety lab?
Oh, yeah. It will make what they're doing with the Hayabusa and OSIRIS-REx samples look simplistic.
Yeah. It'll be like the Andromeda strain.
Hopefully not exactly like the Andromeda strain.
Yeah. One good idea that I've heard was to take them to the International Space Station and open them up there. I mean,
I've heard that too.
It would be a pain to manage the Delta V, but.
And I also don't know the longevity of the International Space Station as compared to the mission to get there, gather the things, and come back, because the ISS is starting to hit the end of its planned life period.
Yeah.
And this is where we're starting to look at things like the Deep Space Gateway and stuff like that. And Bigelow's looking to build a hotel.
Fine, they'll return to the Chinese space station.
So I honestly wouldn't be surprised if it's probably going to take at least 10 years before they're bringing something back. We could conceivably finally have the inflatable modules working on the regular and just build a special protocols lab just for the Mars samples. Right. I don't know if anyone's thinking about that. I don't know if that's on anyone's plan, but we're going to be getting to the point where that's a conceivable possibility.
And so what are the risks? I mean, why would we want to have these samples in a biosafety lab?
Have you met COVID?
Unfortunately not. Yeah. But I mean, partly we don't want to infect the samples. So that's like half of it. And then we don't want the samples to infect us. Although that's less risky than a virus, which has been evolving in various organisms here on Earth that are closely related to us. Something that's been entirely disconnected from Earth for billions of years is probably not ready.
I'm thinking of all of the really gross bacteria we have, like flesh-eating bacteria. I forget the scientific name for it. It's the bacteria that worries me more, because viruses have to be at least compatible enough with your DNA to insert themselves. Bacteria, they're perfectly happy as self-sustained little critters that can nom on you and create nasty waste products that poison you.
Right.
So it's the bacteria that perhaps I lack imagination, but we already have brain-eating amoebae. Yes. However you pluralize amoeba. Yeah.
Tesla Ranger asks, is Ingenuity fully autonomous, or will it partially be controlled by Perseverance?
It's given orders from Earth via Percy to Ingenuity. But the orders are things like go up to 5 meters, hang out at 5 meters, go left 50 feet. And then it uses all of its onboard equipment to make sure it's actually doing what it's told to do. So it's it's essentially a game of Simon Says. Mm-hmm. And the muscle control, or in this case, the rotor control, is all done autonomously.
And so the glitch that it had just today,
it dropped a frame. It literally dropped a frame. Have you read about this?
It dropped a frame because I thought it had to do an emergency landing.
So it did, but what happened was they used two different systems to control the helicopter. One is all of the accelerometers on board, and it's basic eye moving through the air sensors and stuff like that. And the other is imaging the ground underneath and keeping track of where it's supposed to be versus what it sees. And those images coming in all are supposed to have consecutive timestamps. Mm-hmm. And then it reacts to what it sees in the images with the timestamps to calculate how it needs to fix things. Except from the reports I read, it dropped an image frame. So all the images ended up one off on their timestamp. And so the helicopter started trying to respond to images that were from a different time than when it thought it was, which is like trying to drive a car with a 5-second delay built in. Mm-hmm. You're not going to succeed so well. And its systems were like, okay, this is bad. And it's designed to only use its accelerometers when it's coming in for a landing. So when they switched to, it's time to land now, everything went perfectly smoothly because of how they basically have these multiple different systems in place to keep the little helicopter safe.
Raphael Domenichini asks, in a telescope whose primary mirror is made of multiple hexagons, does each hexagon have the same shape? Are they flat, or do they have any curvature?
They generally have curvature. Exactly what kind of curvature depends on how much money you're willing to spend on the telescope. They, in some cases, use spherical because then you can just replace any one mirror with another mirror. But in fancier systems, they do have more complex parabolic or hyperbolic curves. I don't know if they've actually done hyperbolic with a multi-segmented mirror. Mm-hmm. I know they've done parabolic, in which case different mirrors pretty much have to go back where you took them from.
Right. That's interesting. So that idea of a spherical mirror, like when you just have a single lens, usually they are a parabolic mirror. Like if you just got like the 10-meter Keck telescope, you're going to have a parabolic mirror. But if you're going to have multiple mirrors, then you're going to have a spherical mirror. And then, as you say, each one could be swapped out. So they may have a spare ready to go. And if any one of the telescopes, any one of those mirrors breaks, you just drop in a new one.
Well, and more to the point, you hope you don't ever break them. But more to the point, with a single mirror, you have to resurface the mirror periodically. And that is a special nightmare of removing the mirror, putting it into a chamber. Well, if you have a multi-mirror system, you pull off 3 mirrors, you work on those 3, you drop 3 spares in, and you just systematically go through pulling things out and dropping them back in.
And one of the other advantages with spherical mirrors, like when you think about some of the largest radio telescopes, things like Arecibo and FAST, they are spherical mirrors. And so instead of having to move the mirror, you move the array. Yeah, you move the secondary around, and then you're just focusing at new spots because you're bouncing light off this entire piece of a sphere, which is a pretty cool thing. So very cool.
Over on Twitch, there's the most disturbing conversation going on. Like Bad Panda points out, Legionnaires is a bacteria, I believe. And it's just like they're discussing all the ways we can die. Yeah.
I feel like we made it really clear that the universe is trying to kill you.
Mm-hmm.
And that's just bacteria is in the universe. Richard Drum asks, Fraser, did you save a monophile? Yes, Richard. Yes, I did.
So Vaharna.
Oh, you got some questions.
Vahanara? No, I'm trying. There's a lot of letters in this. I'm sorry, but they ask, does rover have the ability to help the helicopter if it tips over? I don't know how.
I'm sure they would
rigorous-
try. Because
Yeah, so I'm just trying to figure out, would the thing bend a lot if it fell over?
yeah, like, people are asking questions like, could it pick up Ingenuity and dust off its solar panel? It doesn't have any grabbing, clamping tools built on. I mean, the Ingenuity is really an afterthought.
Yeah.
Someone was like, we did it. We made a helicopter that can fly on Mars. And people were like, oh, there's just enough time to bolt it onto the underside of the rover. And that's how we got a helicopter. I mean,
the sample tube arm has the ability to grab and move, but it's designed for sample tubes.
But if
the helicopter is not a sample tube.
But if it like landed and like one of its legs or two of its legs and it sort of fell over, could they take its arm and just sort of jam it underneath and flip it over? Maybe.
I suspect that they would try.
Yeah.
It would also depend on when it tipped over and if it affected the ability of its solar panels to charge before they were able to get it back upright. It's purely solar powered. Once it cools off, it's dead.
Yeah, and Nancy is saying, from what she understands, the blades on Ingenuity are so fragile that if it tips over, I suspect they would be severely damaged. I mean, they would try. Like when you think about some of the most incredible stories in space exploration and science, on science missions, it's when people come up with super clever ideas to solve a problem. And so who knows, they may take the laser and zap away.
Yeah.
They zap away sand underneath part of the helicopter to get it back upright. Who knows what they would do?
I don't think the laser's quite that strong.
I'm just coming up with creative NASA solutions.
So
they would use the solar wind to...
No. It's my turn to shamelessly plug, though. Except I'm going to shamelessly plug Annie. So on Wednesday's Rocket Roundup for Daily Space, we did this week's space history on Skylab. And Annie and I were losing it going over the history of Skylab because it is basically all the leftover parts they found at one of the NASA centers and glued together, essentially.
Yeah.
And at one point, they essentially had the hatch open on an Apollo module with an astronaut hanging out with a tree trimmer while they flew around. They were trying to repair things the way, like, someone standing in the back of a pickup saying, hey, Joe Bob, can you hang a left so I can get this limb a little better?
Yeah.
And at one point, Skylab yeeted the astronauts. They released, I believe it was the solar panels, and the practice setup they had lacked the verve that the actual spacecraft has. And the astronauts got yeeted and were rescued by their tethers. It is the most ridiculous mission. I knew nothing about how crazy it was prior to this. Go listen to Rocket Roundup for this week.
That's cool.
It's wild.
That's a great story. Was it someone was saying this? And someone was saying that just how much work was put in to try and save Insight's mole. That they tried everything. They tried digging. They tried putting the shovel on top of the mole. They tried all kinds of stuff. And
they're now burying the cable for the seismometer. So the cable that runs to the seismometer was getting caught by the wind and creating noise in the data. And so now they're just like shoveling dirt onto the cable to bury it. It is the most enduring thing I have ever seen. from a robot.
Yeah, like all missions should also have a little backhoe on board.
Yes.
It's a very helpful thing. So Jerry Lehane says the upside of the Mars killer atmosphere is that the Mars people and animals must be adapted against cancers. So a cure for cancer. I've heard this quite a bit. Do you think we have to cure cancer before we can send people to Mars?
So there are various kinds of, I believe, sharks that don't get cancers.
So we send sharks to Mars.
Yes.
Yeah.
But for realsies, we have all the critters we need on Earth to explore these questions. And now getting to the bottom of the ocean is a challenge, not to be laughed at. But at least it's easier to do incremental design when you're designing things for the ocean than when you're designing things for Mars. So we really need to figure out why some animals here on Earth don't get cancer. It's one of those questions that is deeply interesting.
Yeah. I mean, you just live underground. That's
Yes,
the solution.
The mole humans of Mars, which sounds better when you say the mole men of Mars, but that's inappropriate.
Yeah, you get a few feet of regolith over your head and your risk of danger has disappeared. You also now have to live underground on Mars. So
yeah.
You're doing that anyway. There's no way around the fact that your life on Mars will be underground. Let's see. Arjun asks, could a hopping robot be an Ingenuity stand-in on the moon? Maybe even to explore a lava tube without risking astronauts?
So we know that they work on asteroids. I'd have to run the numbers to see. I want to say that some of the original Google X Prize missions
there was a plan to build a hopping
mission plan.
Yeah, to build a hopping rover. In fact, wasn't the Space IL plan to land and then make a hop?
I don't remember.
Yeah, I think
we'd have to ask Yov.
Yeah, I think that was the plan. Is they were gonna try to win just by landing and then hopping the entire distance to get to the end point. James Dugan asks, is the wind on Mars able to tip the chopper over in a dust storm or dust devil, or is it simply not dense enough?
I don't think it's dense enough. I don't think the helicopter has enough cross section for the wind to really affect it like that.
Yeah, I've mentioned this. You couldn't fly a kite in a hurricane on Mars. That's how low the air pressure is. So,
it's the one thing that Andy Weir knew he got totally wrong when he did The Martian.
And we won't let him forget it. It's funny. I listen to a bunch of podcasts, and whenever this comes up, everyone makes that fact. Like, poor Andy Weir. Like, come on, everybody. Like, just let up on Andy Weir. He took a risk. He got caught with his hand in the science cookie jar, and we're all just grinding him for a decade now.
And he has a new book out.
Apparently, it's super good. Better than his moon book. So, but nobody has reached out to me to interview him, or so maybe I need to make a call. Because I've interviewed him every time. So yeah, I'll do that. I'll call Andy, ask if I can get a copy of his book, and then I'll interview him for you.
Sounds good.
Not you, Pamela. For them, for the people watching. Yeah, he knows. He knows he did it. It was a calculated risk. He's fessed up to it every time, but we still won't let him drop it. Raphael Dominichini is asking, what would happen first with James Webb? The unfolding of the mirrors, the solar shade, or moving to the L2 point?
L2 point first. Mm-hmm. Beyond that, I don't know. And I'm really angry because now they're having rocket issues.
Yes.
So it is, you probably know more about this than I do.
Yeah, Ariane 5 has had a couple of issues with its last two launches. That it failed to deploy its upper stage properly, or problems with the fairing. Anyway, that is causing NASA's GAO to want to go back to square one and say, is there anything wrong with the Ariane 5? So, but yeah, so how long do you think it's going to take? I don't know if you have this number off the top of your head. How long do you think it's going to take for James Webb to unfold all its actuators?
It's a couple months, I'm pretty sure.
A month.
Yeah.
1 month of unfolding all of that. There was a paper that I just saw just a couple of days ago, which I thought was wonderful. Was someone was planning to build mini James Webbs out of CubeSats.
I saw that. That was cute.
Yeah. So it'll sort of deploy, like, it'll have a spherical mirror, and this is where we get this idea, and then it has 4 little panels that pop open out of the end of the CubeSat. And so then and then it's sort of partway back. And so you can imagine sort of like a flower of a CubeSat. And so then the light bounces in. It's got a secondary mirror inside. And so you can increase the total surface area. There you go. Michael Meyer saying, no, the Ariane problem is vibration when the fairing separates. Didn't I say fairing problem? Anyway, yeah. I think that's it specifically.
So there's currently a petition going around asking NASA to change the name of JWST because James Webb was bad for the LGBTQ community. We're just going to go with bad.
Yeah.
And the other day, before the latest petition even started its rounds, Ali said something that is my new headcanon, and that's the mission refuses to launch until it has a better name.
It's kind of weird, right? Because you've got Nancy Grace Roman getting named after, and she was NASA's top astronomer, right?
Mm-hmm.
Yeah. And then on the flip side, you've got someone like James Webb getting the possibly unnamed. So I haven't dug enough to have an opinion on this. And so I don't know, when you say bad, I don't know specifically what the bad was, because I had heard there was controversy as well. So, like, that it wasn't necessarily bad, and so I definitely need to look into it before I form an opinion of exactly why.
There was one person who made an attempt to recontextualize a bunch of information to remove the badness. But no.
Yeah. Yeah, no, if you did bad things, then no mission named after you. That's the rule. If you do good things, then you get missions named after you.
Yes.
Or asteroids.
Or both.
Okay. Raphael Dominichini is following up. Why not unfold the mirror and shade in LEO and then move it to L2? In
Angular
Leo.
momentum.
Yeah,
change.
it's on a trajectory that's going out to L2. It's a 1-2.
Well,
it's
and
launch,
the other way to
upper stage to L2. You're not going to stop, have it sit there, and then fire up a different rocket. Like it's going to one place.
It's also, once unfurled, it takes much more care to move it correctly.
Mm-hmm.
The way to think of it is, if you have all your Tinker Toys in a nice little tight bundle, that is easy to move around. If you bump it, it's going to move the way you expect it to. But if you then build those Tinker Toys out into this massive complex shape, it has the same amount of mass. But now if you poke it, because that mass is distributed in a completely different way, it is less predictable intuitively what exactly is going to happen, because the center of mass is in a different place. You're now providing a torque at a weird angle off the center. You have different lever arms involved. Keep that stuff packed tight in a nice, easy to maneuver bundle until you get it where it needs to be, and then make it a chaos monster.
I'm surprised you're spending all this time talking about a mission that has not launched yet. You got tricked. All right. All right. We've reached the end of our hour, so we should wrap things up. Thank you, everybody, for joining us today on this episode of Astronomy Cast. Just 4 more?
Something like that, and then summer hiatus.
It's 4 more and then summer hiatus. So binge now and join the Weekly Space Hangout crew if you haven't already to keep you entertained over the long, dark summer. WSHcrew.space. Join that amazing community. All right, Pamela, thank you so much for hanging out, talking astronomy with us. Thanks to all of the moderators. A special thank you and triumphant return of Nancy Graziano for helping keep us on target. Nancy's mentioning the upcoming stay on target. 1, 2, 3, 4, 5. So 5 more weekly space hangouts. I don't know if Nancy posted the upcoming Astronomy Cast, although we may be mucking with it because of the Dark Energy Survey. Sorry, Nancy. It's how we roll. So thanks everyone watching on YouTube and on Twitch. We couldn't do this without you. Thanks to all the patrons for supporting all the work we do. If you consume a lot of our content and you're feeling an overwhelming guilt, that's because you want to donate to our Patreon. It takes all that guilt away. All right. Thanks everyone. And we will see you all next week.
Bye-bye.
Where is the button? There it is.